Chapter 6.4 is on the Algebra of Functions. And this is algebra class, so that's a good idea, to look at some algebra. So let's get to it. 6.4 is on the Algebra of Functions and the composition function as well. And we have practiced the composition function, but we didn't call it that, so you might not have known. But we're gonna give a try to this. So if you have two functions, f and g, then f plus g, if you add those two functions together at an input x, then that is the same as evaluating f at the input x and adding it to g at that same x. And same with subtraction. And if you want to do subtract two functions, f minus g at x, then it's f at x minus g at x. And multiplication, same. And division, same. And then function composition, and that is a little circle, f composed with g. Some people say fog is what they say, but it is an open circle is what it is. F composed with g is function composition, and what it is equal to is f at g at x. And so this little diagram here kind of shows that you're putting apples into the function g, because that's what would be done first, and it's spitting out so apples in, lemons out, I guess, and then the lemons are an output for g, but then they're going to become an input for f, and then it spits out tangerines, it looks like. And in fact, that sounds kind of good. Maybe I'll go get me one. And so that's kind of how that goes. And so we're going to try some problems here. This is problem 2 out of your textbook on section 6.4. Remember, there are videos that go with the book as well. And all of those videos are right now online for free, thanks to the generosity of XYZ textbooks. And so on the first lab, I showed you how to go on and look at those chapter 0. That's not the first lab, but the first notes that you have. And so it's the same. And now you can click on any chapter and watch the videos. Anyway, okay, so by definition, f minus g, now they didn't include the x, so this is shortcut notation for at x. And so by definition, this is equal to f at x minus g at x. And anytime that you substitute, parentheses are implied. And so parentheses right here for wherever I'm going to put in for f at x, and parentheses for whatever I'm going to put in for g of x. And that's particularly important when you have subtract, because you guys know what's going to happen with subtraction. You're going to have to use the distributive property. So f at x, this says go to the function called f. For the input, use x, which is the dummy variable. Well, that's exactly what this is. The function with x in, and so it spits out 4x minus 3. And g, same dummy variable x, is 2x plus 5. And now I would just have to practice my chapter 4-ness. You know, I'm going to distribute this negative right here. When you subtract, you distribute the negative. So minus times 2x, some people like to put a 1. Minus 1 times 2x is minus 2x. Minus 1 times 5 is negative 5. Subtract 5. I realize that's an add of a negative. And now I'm going to combine like terms. And my like terms are these x's. 4x take away 2x gives me 2x. And negative 3, and I'm going to be adding with that with negative 5, and that will give me negative 8. So they're both negative, so you would add them. So this is negative 8. And then we're done. That's our answer. You don't have to factor it or anything like that. They're just asking you to come up with what f minus g at x would be equal to. And that's what it's equal to. 2x minus 8. And so you could factor it, you're right, but it's not asking you to do that. And so just, you don't have to do that. So this is f times f. Notice there's not even a dot in there to show multiplication. So whenever there's an operation without showing it, it's multiply. And this is, again, shortcut notation at x. So this is f at x times f at x is what it's equal to. And now remember, f of x was 4x minus 3. So again, my parentheses, right? And I'll put my times there. The time's not necessary when it's butted up to parentheses like that. So I'm just putting it to really show it's times instead of it's add or it's divide. And f was 4x minus 3 and 4x minus 3. And when you multiply a binomial times a binomial, you use FOIL is what you use. You might recognize that since these are the same, that there was a fancy formula that we learned in chapter 4, but I have to admit that I don't use the fancy formula, I just use FOIL. So I'm all 4x times 4x is 16x squared. And minus 12x. And another minus 12x on the inside. And a negative 3 times a negative 3 is a positive 9. Make a note to myself that, hey, I should have more room here. And then I'm going to combine like terms. That's negative 12x and negative 12x. When I add those together, because they're both negative, is negative 24x. So this is 16x squared minus 24x plus 9. And they don't want you to factor in anything. And in fact, you just came from it being factored. You kind of chase your tail. So they're actually wanting you to multiply that together. Okay, so we did a lovely job on those. And I see that I'm at the end of where I can go without moving up. So I'm going to move up a bit here. And I'll be able to do this problem. And then I'll have to move up again to kind of talk to myself about my moving up. So here we've got h take away f times g. And so this is shortcut notation for at x. So when they write it without the x, it's there. If they want it to have some special x, then they're going to tell you what they want there. And if they want just x, then they can leave it without it. And so this is equal to h at x minus f at x times g at x. And so each one of them, I'm going to evaluate at the x, and then I'm going to plug all this stuff in. So let's see what they've told us. They told us that f of x is 3x minus 5, and g of x is x minus 2, and h of x is this. So these are all at x, and so I'll put all of those down. Parentheses are implied when you substitute. So I'm going to make some parentheses here for my h of x, which is 3x squared minus 11x plus 10. And I should make my parentheses, and then I should fill in the blank and then make my parenthesis, right? Because I don't always make it big enough. And then here I have 3x minus 5 and x minus 2. And you have to be careful, because when you multiply this together, when I FOIL that together, I'm going to end up with 4 terms, and then I can combine like terms, and then I need to distribute the negative to those 3 terms. You know how that we've kind of gotten used to when we multiply that together. So I want to remind myself that I'm going to have to distribute the negative, so I'm going to do like parentheses like that. So 3x times x, so I'm foiling, is 3x squared minus 6x minus 5x. I really need to put more room on these. And then plus 10. This has been a good experience for me. And so when I add the like terms in the center together, that's negative 11x. So I kind of got a little lazy there and didn't want to write that other part over there, since it wasn't, those two together are negative 11x. Better be careful while I'm talking. And now I'm going to distribute this negative. So I have 3x squared minus 11x plus 10. And hey, that's what I have there too, isn't it? So when I distribute my negative, gosh, that negative got crazy low. I'm going to move it at minus, right? So when I distribute my negative 1 here, this is going to be, so I have here 3x squared minus 11x plus 10. And then I'm going to have minus 3x squared, and then plus 11x, and minus 10. And so you can see that I got 0, right? So 0 is my answer. So those made 0, that made 0, that made 0. So this whole thing is equal to 0. So this was equal to that, equal to that, equal to, and equal to 0. Okay, so we did a nice job on that one. And these, I think, are actually a little better than those. In my opinion, you can see what you think, because these are asking at a certain number. And I kind of like them when they're asking at a certain number. So this, by definition, 28, have I got it so that you can see it? Yes, I have. And so this is f at negative 1 minus g at negative 1. And just like, and we did these, now that I've written it that way, they had us do those in 6.2. So if you practice the homework for 6.2, then you've done a problem like this. So you're going to go, this says go to the function called f and replace in for x, instead of x, put in negative 1. And so I kind of like to have my side scrap paper here. So f at the blank equals 2 times the blank plus 1. And they're asking me to put in negative 1 in both spots. For x, put in negative 1. And when I do the arithmetic, I get negative 2 plus 1, which is negative 1. Coincidentally, negative 1. So this whole thing, f at negative 1, is equal to negative 1. And then subtract, subtract. And now I'm going to go find out what g at negative 1 is. So g of the blank equals 4 times the blank, whatever you want to fill in there, plus 2. And what they would like me to fill in there is negative 1. So put in negative 1 here. And then I got to do the arithmetic. And I'm going to know what g at negative 1 is. And so that's going to be 4 times negative 1 is negative 4. Plus 2 is negative 2. And so this is negative 1 subtract negative 2. And you can put parentheses there if it makes you happy. Negative 1 plus 2. So this is 1. And we did a lovely job on that. And so you can do these in your head, or you can write it out. I kind of like to write it out, particularly for people who are just learning how to go. And then this is number 38, h minus f times g at 5. So everything is going to be evaluated at 5. And so we're going to have h at 5 minus f at 5 times g at 5. So we need to find out what all of those pieces are, and then we'll be able to do our multiplication and our subtraction. So I want to find out what h at 5 is. So h of the blank equals 4 times the parenthesis squared plus 4 and then the parenthesis. So instead of x, I put the parenthesis, and you guys know that I have been doing that since we started substituting, which is in chapter 0. And I put parentheses where I'm going to substitute in. And what am I supposed to substitute in? 5. And your choice on whether or not you do that with your head or with your calculator. And I just decided, hey, I'm going to get my calculator out here. I love this calculator. Someone I like very much gave it to me. I'm going to tell him, hey Sam, thanks for the calculator. And I wish I wouldn't have broke it in my purse, but it still works really, really well. And it's my favorite Casio calculator. And I thought that in my calculus video that you could see my calculator screen. And so I'm going to see if you guys can see my calculator screen. So I'm punching in the buttons here. And I love that I can see what I put in. And so I can kind of check it and make sure. And so I'm getting 121. I love 121 because it's 11 squared. I don't know why I'm such a nerd. I just love squares. Perfect squares are my favorite. And so F at 5, going a little stir crazy at my house, you can probably tell. And so this tells us F, remember, was 2 times the blank plus 1. And so we're going to put in 5 there. And you could use your calculator for that as well. 2 parentheses 5 plus 1, just exactly like you see it, which is 11. Of course, you could do it with your head as well. And I also need to know G at 5. So I'm going to find it here on my scrap piece of paper. For G, so G is 4 times x plus 2. So where I have x, I'm going to put parentheses. And I'm going to put in 5. And so 22, right? And you can do that with your calculator if you like as well. So now I'm going to fit in each of these pieces. So H at 5, I did the work. It was 121. Minus F at 5, I did the work. It's 11. Times G at 5, I did the work. It's 22. And then, of course, you could put that in your calculator, just like you see it. 121 minus 11 times 22. And I get negative 121. And there's your answer there. So we did a nice job on that first page of 6.4. And it was pretty good. And so I think there's another page here to look at as well. And so let's see what we've got going here. So these are the function composition ones. So we're going to give a try to them. So we're going to have to use our definition of function composition. And so I'm going to put that definition up here. F composed with G at x is equal to F. And you can use parentheses or you could use brackets. And what I like to do is use big parentheses. And the book uses brackets, and it doesn't matter. But and I want to tell you order matters. Whatever is here, whatever F composed with G, whatever's first goes on the outside, and then the next thing goes on the inside. So if they change it around on me and ask me about G composed with F, which they do, ask me that, then it's not going to be equal to this. It's going to be equal to having G on the outside. So G is the outer function, and F at x is the inner function. And you can use brackets there, or you can use big parentheses like I've done. So here we're going to give a try to it by definition. So that's that open circle that you have there for function composition. A lot of times people tell me, I thought it was a time symbol. And so let's think about how a time symbol looks different. A time symbol looks like this, solid, where a composition looks like it's not solid, it's hollow, right? And so open circle there. And so you have to be careful, in other words. So this is asking me on 39A, it's asking me for F composed with G at 5. So this is F on the outside, and then G at 5 on the inside. And we practiced those. We didn't say it was function composition back there in 6.2. And so kind of on our side paper over here, we said, well, we got to do G first. So this has to happen first. So G is equal to the parentheses plus 4. And whatever you put into the parentheses, they have the dummy placeholder x, but they're saying now put in 5. And so when we put in 5, we get 5. So this function notation is some substitution, right, that we're using right here. 5 plus 4 is 9. So G at 5 is 9. So where I have G at 5, I'm going to replace it with 9. And then that tells us now 9 was the output for G. Now 9 is the input for F. So we want to do this with F. So F looks like this, F of the blank parenthesis there, raised to the second, and you're putting in 9. And so when you put in your 9, 9 squared is 81. So this is 81. And my scratch paper over here, I like to put it on the scratch paper over there so that I can kind of see what I had and whatnot, and doesn't gum up my work a lot over here. Your choice, right? How you do it. I'm sure that if you went and watched the videos, you would see other ways of doing it that you may like better. And so, or you might like how I've notated. Either way is good. Eventually, as you practice it, you'll be doing this part, I think, in your head more. And so, and it might not be this semester. It might be in pre-calculus that you go to in your head a little more on that. Okay, so 39b is G composed with F at 5. And so that is this. And so we're going to write this out. So this is G at F at 5. And typically these are not the same value. F composed with G at 5 and G composed with F at 5 are not typically the same value. They wouldn't be the same value for every function F and G. But they might be the same, and then those are going to have a special name, and you're going to learn about those when they're equal. When these actually give the same result, it's special. And so I don't think that's going to happen here. And so first we're going to do F at 5. So the F function squares it. It's a squarer is what it is. So you put in 5 and it squares it. 5 squared is 25. So this is going to be G at, and I'm going to replace instead of F at 5 with 25. So this is G at 25. And then what G does to things is G adds 4. So we have our I like to write it with the fill in the blank. So fill in with 25. 25 was our input, and we're going to add 4 to it, and we're going to get 29. So this is 29. And so this, again, is my work that maybe someone else would do in their head, but that's the thoughts as you go through the problem. Okay, so now we're going to look at 39 C and D and see how we do. And let me see, I stood up to see if I've got my video in the right screen, and my cell phone caught on the chair. So by definition, this is equal to F at G at X. And now it's the dummy X, right? And so G at X is right here. It's X plus 4. So I don't really have to write anything for it. If I did, this is how it would look. G, the blank, equals the blank plus 4. And what are they saying to put into the blank? They're saying to put in X. And that's what I'm used to. And I don't need parentheses around that, right? And so this is just X plus 4. And so this was kind of silly. I was being silly, right? But just so you know, that's the output there. So this is F. And then instead of G of X, what did we find it was? It was X plus 4. So we're going to put in here X plus 4. And then now this says go to the F function. And remember, the F function is a squarer, is what it is, something squared. And what are they telling us to put into F? X plus 4. So right in here, it's going to not hardly fit. X plus 4 makes you think, hey, why don't you write the X plus 4 first? Because that didn't fit at all. So I'll make this a little bit bigger. X plus 4 in here and X plus 4 in there. So the output there is X plus 4 squared. And so right in here we get X plus 4 squared. And so that's what that's equal to. And so there's our answer there. And our answer here was 29. And here our answer is X squared, X plus 4 squared. Sometimes in the back of the book, they physically multiply that out, and sometimes they leave it just like that. So if they did multiply it out, I would want to try to match them. X plus 4 times x plus 4, right? That's what it means to square that. And that's x squared, x times x, plus 4x, plus 4x, plus 16. So this is x squared plus 8x plus 16. So I have to admit I was going to look and see which one they had in the back of the book because I forget from time to time, and I've seen both when they're asked, because they didn't really ask me, you know, leave it in factored form or multiply it together, and so both of those answers are kind of good. And so I'm going to look right now and just see in the back of the book. I hope that you check in the back of the book of what kind of answers that they put. That kind of helps, I think, to make sure of what you've to compare. So this is 6.4, and this was probably 39A. So I would be able to look this one up, which usually I can't look them up and see. I just have to look on the general. So where is 39? Yes, they left it here, x plus 4 quantity squared. And I told you I'd seen both, so I wasn't sure which one. So this one, g composed with f at x, I don't expect that I would get the same answer for it. So I'm gonna give it a try and see how I do here. So this is gonna be g at f at x using the definition, right? So that's what that is. And again, the first one's silly, right? Because f is a squarer. And what are they putting in? X. So the output is just simply x squared, right? And so this is g at x squared. And then remember what g does. G adds 4 to things. And so it's an adder of 4. So what are we going to add 4 to? We're going to add 4 to x squared. So in our input, we're going to put x squared. So this is x squared plus 4. So this is, and those parentheses there are not needed, right? I put the parentheses just in case. So x squared plus 4, because there are times that they are needed. And so that's your answer there. And there wouldn't be anything that I wouldn't be saying, hey, do they want me to multiply that together? Because that's just done. And so we've done a very lovely job on that. Okay, I hope that you give a try to Thursday's daily incentive point problems and hold on to them. And I'll be shooting more videos, and I'll be trying to work on a way of doing some office hours as well. I almost didn't have that on the screen, huh? And so anyway, okay, we'll talk to you guys later. I'm hoping that you're having fun working from home. Bye-bye.